Let's do a quick problem. I know this is a prefix sum problem with the hash map. So yeah, let's try to. I think the intuition is kind of tricky. Obviously the brute force. I've done the brute force before, or like I've seen like how it can be done. But the prefix one is more interesting. But we'll see if we could try to code it up. Because I know the intuition already, but I don't know how to code it up. So let's try to see if we can do that today. So given up an array is basically find all the subarrays that equal to k. For this case, it's 2 because there's this way and this way. And subarray, they have to be contiguous in the same order, so you can't change any of the ordering. But how do we do this? So we can do this by, okay, so the idea of brute force is we'll calculate all the subarrays. So let's find all the subarrays that I can generate from this nums here, right? So that's simple. Like we can do 0, we could do 0, 1, we could do 0, 1, 2, I could do 1 and just 1, I could do 1 and 2, and then I can do 2, and that's it, right? That's these are all the combinations, and then there are, like, I'll also put the sum here. So the sum here is obviously 1, this is 2, sum here is 3, sum here is just 1, sum here is 2, and sum here is just 1. And the answer here, there's 2 of them that equal to k being the sum. There's 2, but there's a lot of, this is definitely n squared, and I believe it's a lot of numbers, so definitely will TLE, I believe, but I'm not sure. So that's the brute force way, but okay. The prefix sum way is, okay, let's compute how, like, the sum up to the index you're on. So for example, we'll say 1 is here. 1, okay, so we go through nums of 1. Right, we have 1. What is this current sum up to? So we're saying, okay, so we're saying up to 0, index 0, what is the current sum? That's 1. Up to index 1, right? This current sum is 2. Up to index 2, what is the current sum? That's 3. And the idea is, as soon as you detect a sum that is equal to a subarray, that is helpful for us, because that tells us how many other subarrays exist, right? Obviously, yeah, so 0 to 1, that's the prefix, how that prefix works. But if you also keep a hash map, a map that stores the prefix count, prefix and the count, that will be also helpful for us, because once we detect a subarray that equals to the sum, we want to find numbers when we take away their prefix, that also kind of generates. So for example, like for example, once we reach index 1 right here, when k, that's already 1. So if we say 2 minus k, which is 0, we are saying here 2 minus 2, right? So this is our current window, right? We're saying 1 to 1 to 1, and our current window is like this is our subarray, and that's the sum. So we detected a answer. That's one subarray. How many other subarrays can we find to make this still 2, right? Well, we can obviously take away nothing, because just leave it as is. That's one answer, right? The 0 represents here, the 0 represents, there's the count, well, okay, this conveniently has has the same amount of hash maps, but we're also going to keep track of all the prefix counts. The prefix count of 2, there's just only one of those. Prefix counts of 3, there's only one of those, right? So we have the ones here. We have the 2 minus 2 here. Yeah, so the prefix and the count. Oops, let's do this. Kind of straightforward. Yeah, so we could do that 1 and 1. So we look up here. So we're saying, okay, the current sum is 2 minus what we want. 0 will tell us, if you remove any prefixes that in your subarray that equal to 0, those also will help you get your answer. In this case, there's only one of those. That being, one of the solutions being, don't take anything out. I think there a better example would be, like, let's do another example. Let's do 1, 1, 1, 1, 1. 5 ones. Oh, we could make this like a -1 or something, right? Actually, yeah. Let's just do 1, 1, 1. So if you do this, the current prefix is 1. The next prefix is 2, 3, 4, 5, right? Prefix meaning like the sum up all the numbers from 0 to that index right here. So that's why it's 2, 3, 4, 5. And then let's say k is supposed to be like, we want to find all the subarrays equal 3. So for example, this here. No, is this a thing? Also, I think a base case is to have this as to 1, because by nature, that just makes sense. There are one way to make a subarray that equals to 0 by just not taking any of them. So that's going to be there automatically. Then the next idea is, okay, we have here 1. No. We have another idea. We have another count, which is 1 here. Right? That's our subarray. The next one is 2. There's one of those. There's another one here. There's 3. That's actually a big one right here. That's 1 equals to k. Now, can we make any other ones any other ways? No. There's just only there's one way, which is itself, meaning don't take away anything. So from here, let's do another one, 4. So we've never seen 4 before. Now we should still do that, like check first, right? Is there any other ways could I create that? So like, okay, for example, right now the sum is 4. So 4 minus 1, or 4 minus 3 equals 1. That's what we're saying. The current prefix, right? The sum of this minus our target. This will give us the prefix sum of the sum to get rid of. So for example, how many ways were there to create 1? Well, there was only one way, which was taking out the end. So that gets us this one. So therefore there's one way from prefix 1. Let's do a 5. We can also do the same thing. The 5 will be 5 minus 2 equals 1. Or not 2. 5 minus 3 is equal to 2. So we're saying from here, any prefixes that equal to 2, get rid of them right here. So that was, remember when we did that, which was right here, there's only one way to do that. So, because if you get rid of these, the reason why we have that is because when we get rid of them, the remaining one is the sum we want. So there's one way. So that's a count. So that we increment that. So therefore there would be like about, I think, 3 ways to create it. There would be one here, and one here. And I defined all that. Let's try to do that. I'm not sure exactly how to code this up. So max, we're gonna by default have that like this because, yeah. And then we'll do for every n in nums. Basically, we can do target is equal to we should probably have a prefix. What was I trying to do here? I should probably fill up the prefix. Prefix of... Okay, never mind out of this. Maybe I'll just make this a map too. Prefix of... Do I calculate this first? No, I should calculate it as I'm going, right? I'll just add it as I go then. Prefix, because, okay, when I'm doing the math here, no, I don't really need this. I just need the prefix. So this is prefix and count. So calculate the prefix, which would be... Oh yeah, can I just keep this as a variable? Just prefix like that? Yeah, I think I can keep it as a variable. Because all I really care about is the current prefix right now, so. So right now the current prefix is 0. Well, I guess I'll add the prefix first and check. Okay, right now prefix is 1. If the prefix equals k, or actually it's more like, okay, if I guess if the target, basically, right, if target, which is basically prefix minus k, is in the map, because we want to check all the time, like, yeah, if it's that, you know. Right, the prefix minus k. So we're saying prefix minus k, which is I should probably have this too, or like res, and then return res. So if what we're saying, what was I trying to, okay, what we're doing here, which is current prefix minus k, right? Look up this in, is it in the map, right? If it's in the map, then yeah, that's a potential answer. So we'll do res plus equal right here, prefix, which is map of prefix minus k. Yep. And then otherwise we just do this prefix plus. I want to increment actually, so I'll do 1 plus map of prefix dot get prefix, otherwise 0. Just increment. Yeah, these are, we're storing the prefix and the count. Yeah, so that maybe should work. Perfect. All right, see you guys tomorrow.